All right, so this is lesson 1 of the probability and data unit. We're looking at calculating probabilities today based on probability tables and probability trees. But first, let's define the term probability. You probably are familiar with this word, but the actual definition of it is it's the mathematical likelihood of an event happening. It's always between 0% and 100%, or between 0 and 1 if you're using fraction or decimal numbers. So just as an example, if you flip a coin, the probability that you get heads, usually we just use the capital letter P to denote probability. So the probability you flip a heads would be 1 out of 2 or 50%. Because there's two things that can happen when you flip a coin, either it's heads or tails. So the chances you get heads is 1 out of 2. So about 50% of the time it's going to be heads. Sample space, we're going to be using this word a lot. It's all the set of all the possible outcomes in a probability experiment. So just as a really simple example, when you flip a coin, the sample space, when you flip a coin, the sample space is going to be heads or tails. When the probability experiments get more complicated, the sample space is pretty large, and there are certain ways that we can represent the sample space to make it easy to visualize. So in this case, we're going to use probability trees and probability tables to visualize the sample space when our probability experiments get more complex. Okay, so let's do a probability table first. Let's pretend that we are rolling 2 dice, and they are 6-sided dice, and we're going to calculate the sum when we roll these 2 dice. So we're going to put one of the dice, so let's say this is die number 1. We're going to put the possible values in each of the rows of our table, and then this is going to be die number 2, and we're going to put each of its possibilities in each column of our table, and then we're going to fill out the table with all the things that can happen when we roll these 2 die. For example, if we roll a 1 on both die, the sum, which I'm calculating here, which is what we get when we add the 2 numbers together, would be 2. If we roll a 1 and a 2, the sum would be 3. If we roll a 1 on die number 1 and a 3 on die number 2, we'd get a 4. 1 and a 4 would be 5, 6, and 7, and so on. And we can fill out this table with all the possible things that happen when I roll the 2 dice. So 2 and 4 would be 6, 7, 6 and 2 would be 8. And I can continue to fill out the table this way by writing all the sums down. So I'm going to go a little bit quicker now. 7, 8, 9. You might see some patterns forming. Just filling out this table with all the possible sums you can get when you roll the 2 dice. 7, 8, 9, 10, 11, 12. There's some neat structures that form here. But we can see there's 36 possible things that can happen. There's 36 squares there when we roll the 2 dice. And so when we're calculating the probabilities, we're going to use this sample space to see how many ways each event can happen. So let's look at the first one. The first one is saying, what is the probability that we get a sum of 2? So that would be, there's only one way to get a 2. You have to roll a 1 and a 1. So there's only one way that this can happen out of the 36 possible ways. So the probability would be 1 out of 36. So if you roll the dice 36 times, this is probably only going to happen once on average. All right, let's do the next one here. So this next one is, what is the probability that the sum is less than 5? So let's highlight all of the sums that are less than 5 and add them up. And see there's 1, 2, 3, 4, 5, 6 of those. 6 ways the sum can be less than 5. So the probability would be 6 out of 36. Now, because we're writing this as a fraction, we should reduce this by dividing by 6. So we'd get 1 out of 6. I'm going to box in all my answers here. Okay, next one. The sum is greater than 7 and it's an even number. Let's highlight all of those. So 8 is greater than 7 and it's an even number. 10 is greater than 7 and it's an even number. And 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9 possible ways that this can happen out of the 36 possible ways altogether. So we can reduce this, divide by 9, get 1 out of 4. So every time you roll the dice, but 1 in 4 times, you're going to get a sum that is even and greater than 7. Okay, last one. You roll the same number on both dice. That's going to be all of these values here. So there's 6 of those. So we get 6 out of 36, which can be reduced to 1 out of 6. So 1 out of 6 times you roll the dice. On average, you're going to get 2 of the same number. Okay, so that's how you use a probability table to calculate probabilities. All right, let's move to a probability tree to visualize our sample space. Now, the disadvantage of a table is that you can only really do it when there's 2 events, like rolling 2 dice. But when you have 3 or more events, you should use a probability tree. So here we're going to flip 3 coins. So we couldn't make a table for this event or this experiment. We're going to instead make a tree. Now you can make your tree go from top to bottom or from left to right. There's different ways to draw it, but we're going to do this from top to bottom here. And we start with the first flip. So flip number 1. Either we get a heads or we get a tails. So you can see we're making branches here on our tree. Now for flip number 2, if I first flip to heads, I can then flip a heads or a tails. And if I first flip to tails, I can flip a heads or a tails. So you can see I have 4 branches now of my tree. So that's flip number 2. Now I'm going to go ahead and do flip number 3. And from each branch there's 2 possibilities. I can get a heads or a tails, a heads, tails, heads, tails, heads, tails. Okay, and if I read along each branch, that will tell me each of the different events of my probability or my sample space. So one possible event here is that I roll or I flip heads, 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 and then you could also get, for example, heads, heads, tails. I won't highlight every single one, but you can see as you read along each branch, heads, tails, heads. You can write down the entire sample space. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. These are all the possible things that can happen. Or tails, tails, tails. So there's 8 possible events that can happen when you flip a coin 3 times. Okay, now let's use this to calculate the probabilities. So the probability that we flip all heads, well, there's only one way to do this. So it's going to be 1 out of 8. All right, next one. Probability that we flip exactly, we'll get 1 heads. So let's highlight that in green maybe. So there's 1, 2, 3 of those. Oops, I highlighted the wrong one there. Not that one. But there are 3. 1, 2, and this one as well. Oh, I highlighted the wrong ones here. Let's start again. I'm looking for events where I only have 1 heads. So that's this one, oh, not that one, and this one. There we go. We found all of the ones with only 1 head listed. So there's 3 ways to get 1 heads when you flip, and so the probability would be 3 of 8. 3 out of 8. Less than 2 tails, so that means we either get 0 tails or 1 tails. If you count those up, there's 4 of those. Then we can reduce this to give 1/2. And alternating heads and tails, that means, so for example, let's highlight those ones. So alternating heads and tails would look like this: heads, tails, heads, or tails, heads, tails. So there's 2 of those. So it would be 2 out of 8. And we can reduce that to 1 out of 4. So we can use a tree like this to visualize the sample space. We especially want to use a tree when there's more than 3 events, or we can use a table when there are 2 events to visualize our sample space. All right, that's the end of the video.